Hello and welcome. This week we're going back into the world of aerodynamics with this unlimited Pikes Peak race car I am currently designing and building. I'm going to touch on a few particular things around the workflow I go and use to go and create the 3D models, and then also how that goes into Airshaper. Along the way, I'll show you some of the development that's been going on with the car so you can get a feel of the journey that I've been going through designing this car ready for the Mountune this year. So let's jump into the computer and see what I got. Okay, what we have here is the car as I basically left it with you in the last episode. This is the completely bespoke design with a tube frame chassis underneath it. That was the intent. And what you can see here, if we look in plan view, how I've shaped the cockpit cabin area. It's quite smooth transitions. Same with the nose cones, quite smooth, one curve for each of those parts of it. So I think visually it looks pretty good. I was happy with that, where that was at this point of the design. And then I introduced the Tatus tub, which I covered on in the previous episode. And you can see here how things like the side pod location went a lot further back, and that's kind of by default of how that tub was laid out. You can also see to get the cockpit to sit nicely, it's this quite awkward line from the top here, straight around the edges and then tapers back quickly towards the rear. And then you also got the tub as well. Those lines there, you can tell the tub's been designed to a set of regulations because it's quite squared off areas, and then the nose ducts down thereafter. So visually is a little bit awkward. Aerodynamically, actually not too bad. If we go over to Airshaper here, you can see this is basically where I left the car in the last episode. Rear wing configuration may be a little different. But in this basic setting on Airshaper, you can see a lift coefficient of -3.65 and a drag of 0.777. So a pretty good efficiency, but not mind-blowing. And then we go over to the Tatus tub, and then the layout here. We're a little lower, lift coefficient -3.562, but then the drag's actually reduced a bit more, 0.703, so efficiency is still good. That might be down to this rear wing layout configuration, but at the time I was focused on it, had a pretty good feel. It wasn't too bad a difference, but making the car work with this layout was a little tricky. So at this point in the design, I was very fresh off 2024 Pikes Peak, and that helped me focus in on exactly what I think I needed on the Mountune. It's been a year since you've last been there, and you kind of forget what that environment is like and what that Mountune needs. And at that point, I realized, you know what, it's a simple, lightweight, bare bones car that I think is going to work really well, rather than a very, like a large car with big aerodynamic devices, enclosed cockpits, efficient, aerodynamically efficient type cars. I could kind of see that wasn't the be-all and end-all for the pace on the Mountune. And that helped me refocus with the Tatus tub, and also realizing I got to make a car in a year. How can I go and pull this together in the minimum viable product to be competitive on the Mountune? So that was very much a refocus point. And I went back to a lot more the concept I had with the Wolf, and then more so even than that by really stripping it down, keeping it a lot more simple. So having seen how the Tatus tub didn't make too much difference in the whole scheme of aerodynamics on that original concept I had, but seeing how hard that was going to be to execute, as in design and make, I thought, well, why don't I make life a little easier for myself, and let's see what I can do with a very stripped down bare bones car. And that's where we'll head back into the computer. So this is my first attempt at a very stripped down version of it, and I was actually using some more of the original Tatus bodywork. The rear engine cover you can see here is part of that original bodywork. I was trying to really reduce the amount of panels I was going to have to make myself. The underside, actually, this is not trimmed correctly how this model is. Let's get rid of those. Boop. Oh, it's crashed. There you go. You get a better feel. So you can see on the underside, I also went to this truncated tunnel floor layout, which finished in front of the rear suspension and then just relied on the rear deck lid to carry on essentially the work of the diffuser. So it's somewhat similar to what this floor layout is compared to like a 1990s, early 2000s Formula Atlantic. They did this very much so. And it wasn't very efficient, but it was pretty effective in making a lot of downforce. So I stuck with this for a little bit. I had some issues in the end with that. It's very susceptible to stall at lower ride heights. So that's not something I persisted with, but I did persist with quite a long time to try and make this work. I liked it because the floor is so short in that regard. One of the neat things I wanted to show you is actually how I go about creating these models and how that goes into Airshaper. So Airshaper is pretty neat in that it will take essentially 2D surfaces and go and run them in the software. Most CFD packages require a volume to go and do that. However, part of Airshaper's code essentially makes anything you chuck in there into be it a low volume, but a volume itself to which will work with the CFD code. So this is great for me because I can go and combine this with Fusion's essentially T-spline modeling. And what you get is this, it's almost like a blanket of splines that you can drag around and manipulate to change the shape of the bodywork. So, I can just click a surface here and I can go and move it around. And you can see, like, for tweaking and morphing and changing the shape of the bodywork, it's really quite powerful. Let's say I want less of an undercut here on the bodywork, I can just select these couple of surfaces and I can pull it out and I get rid of that. There's definitely some nuance to how, getting good at this and how you set up a good T-spline surface. But I found it being incredibly powerful to do very quick aerodynamic changes. So when I'm saying that I can go and do a change, maybe a run in 30 minutes, it's because I'm able to very quickly change the geometry of the model and go and rerun it. So that's where you get a feel for it there. So I can go and save this as you essentially do an export, and then you save it as a mesh file. I use OBJ, it's a bit easier to interact with. Export that to my computer, and then that's what gets uploaded to Airshaper. And this is how I'm going through this workflow. And you set up the experiment, and this is what it outputs. So this was the Tatus tub of the Manta V12 there, and then I went back to this stripped down version is Manta V.06. It's almost like the interim version of car. And I was using quite a lot of carryover parts. The front wing was from the 2019 Pikes Peak car, works pretty well, especially for making downforce. And then I've just got a couple of side pod panels and the floor as well. And seeing how that was doing. And it's also the Wolf rear wing, main element. So you can see here, there's actually quite a big drop in downforce, 0.2712, with still a significant amount of drag. So overall that's been a big degradation when I went over to this simplistic concept for Pikes Peak again. So again, I came to this idea because of just visiting Pikes Peak and getting a feel for what I wanted out of the car again. But I wasn't going to quit on that, and I was going to see if I can get a little more out of it. So I increased the floor size, altered the floor geometry a little bit, and you could see the downforce started to come back. Actually in the previous model, you could see the front and rear lift coefficients were quite similar. So that showed me just the rear wasn't working very well also, but the front was pretty healthy. So I could get it back to that 0.35. And that's what I did here. Again, the drag's a little higher, but not the end of the world. And then the balance is a bit more where we wanted it. So this was actually super promising for me because I've got a stripped down bare bones car where I don't have to tool up too much bodywork and using some carryover parts. And it was within the same ballpark of what I designed with the full Manta That's what I was calling it at the time, that full layout. You think the complexity that's in this car and all the new parts I was going to have to make compared to kind of throwing some things on and setting it up well. Well, this car seems like a great option. You know, I've got really small overhangs. There isn't much bodywork on it. That was looking really, really strong. So I continued to iterate and develop around this. Here you can see I raised the rear deck lid, and that got me a little more downforce. You can see that lift coefficient is going up, 0.346 to 0.3658. So like, yeah, that's improving things, that's helping. So there's still more to be had even in this concept itself. You can see how the floor's working there. You know, we're seeing quite a lot of blue on the bottom, so it's looking pretty good. So this was promising for me, and I continued down this road for quite a long time. Again, tweaking and refining the front wing, getting rid of the gurney flaps and shaping the flaps a bit better. That yielded a bit more efficiency. And here I was actually starting to develop the radiators a little more, and the radiator inlets had to open up a little bit as well. Again, with this basic rear wing, I know I can bolt bigger rear wings on and make lots more downforce if I needed to, but in this base setup, I wanted to keep it pretty efficient. And then here you can see the difference. I'll go and flick back between the two. This is the same car. This one is being run in the basic setting on Airshaper. And you can see here how a lot of the suspension goes missing, you know, is partially created in the model, and how, you know, a lot of the flaps are closed up, flap slot gaps, sorry, are closed up, and all this. So this is the challenge you have when you're using the basic setting. It's, you know, it's for big changes, not little changes. And that was helpful for these big concept differences, but once you're going into the detail, you can see this medium setting, all the wishbones are now there properly, the slot gaps exist. It's starting to, you know, it had a little support in there, it's starting to model that. That wasn't quite right, but you get the feel for the difference in resolution there. And then in terms of results, you can see for the same model, this one here is drag 0.827, lift of -3.607, and then you go over to here, we're all the way up to -4.114 and 878 drag. So we're gaining downforce and we're gaining drag, which makes sense because, you know, the aerodynamic devices are working more effectively rather than just big bulk shapes. So that's one of the, you know, like a really good example of how Airshaper, what it does between the different resolution sizes. So I thought that was pretty neat. So here we are at the end of this design cycle. We have a very minimal style car using the Tatus tub. It's now open top again. Actually, the difference in drag and downforce with an open top is marginal, and I think a big part of that is the reduction in frontal area when you don't have a closed canopy, and going and putting fairings on, you know, cage tubes can help with that as well. But anyway, this car's, you know, a lot more simple to go and design and make. It's going to be a lot lighter as well than a fully bodied enclosed car. So lots of key improvements there. However, I'm not the most happy with it as it sits because it's still visually not striking enough. I don't think it's going to get people excited. So this sat as my minimum viable product, and, you know, something to do at a bare minimum, and I wanted to go and expand on that and then try and take the car back to a more extreme performance level, aerodynamically speaking, that has a bit more visual excitement to it. So I'll show you that process as I've gone from this, you know, very bare bones car, and then going to expand on that, but not get as crazy as I was with all the enclosed bodywork and the big surfaces. So yeah, stick with me on that one. I'll continue to show you the development process. It was cool to show you a few of the design tools I used. Fusion's T-splines plus Airshaper is the magic, I think. that's what makes for very quick design iterations and changes. So I'd really recommend both those tools individually and being worked together. They've been great. So a big thank you to Airshaper once again. It's been a huge help getting this car to where it is today. The numbers we're seeing in this video now are pretty good, but you'll see some significant improvement on that still with later iterations of the car. So bear with me and I'll show you that in due time. So thank you for joining on this one. Make sure you like and subscribe, and I'll catch you in the next one. Bye-bye.